All right, so we played with awk last week. I'm still like weird. All right. So we played with awk last week. Awk is largely about taking a file and breaking it up into columns. Right? So you have things in fields, separated typically by spaces, but it could be commas or whatever, and you want to do things with the individual fields on each line. Sed is really based on working with entire lines from an input file. So doing things like, for example, making some kind of substitution, getting rid of the \r on each line. And so our general form of the sed command is sed, just like awk, sed program, and then file. And just like awk and everything else, if you don't specify a file, it runs from standard in. And we can also say sed, and if we don't want to put our program here as a command line argument, we can say -f and the name of a file containing a program. Right, so this is the input file. And the normal behavior of sed, so pick on our food file again. The normal behavior of sed is just to read from the file and send it copy to standard out. So if I just say sed, my program is empty, just quote, quote, and I say foods, it reads from foods and it copies it to standard out. Now if I say sed-n, that says read from the file, apply this program, but don't copy the input file to standard out. So that produces nothing. So sed-n, don't copy file to standard out.
Does sed-n change the actual file?
None of this changes the file except for the -i switch, which we'll get to. But this is really just reading from a file and then sending the output to standard out. So if I just do sed and I don't specify a file, it just reads from standard in and copies to standard out. Okay, so what can your program look like? So your program has the general format. It could be an address, and it could be possibly followed by comma, another address, and then some sort of instruction. So in documentation, manual pages, and so on, brackets usually mean optional arguments. So your program could just have an instruction, or it could be an address instruction, or a pair of addresses followed by an instruction. And your address could be a line number. It could be a $sign to mean the last line of the file, or it could be a regular expression inside slashes. All right, your instructions can be things like P, which means print. Could be Q, which means quit. Could be D, which means delete. And a bunch of other things, but let's just play with these. So if I say sed-n3 foods, oh. Not bad. Oh, I need an instruction. Okay, so sed dash n 3 space p foods. Okay, so my address is line 3 and my instruction is print. And I'm saying if I'm reading line 3 of this file, I want to print line 3. Okay, and so that prints the third line of my file, which was apple, banana, Oreos. Right, if you said dash n1 p, it prints apple. If you say 1 comma 3 p, it prints the first 3 lines. Right, everything between addresses 1 and 3. If you do 2 comma 3, it prints everything between lines 2 and 3. This dash n switch is useful because without this, I get all of this stuff. So without the dash n, what does sed do? It reads from the input and it copies it to standard out. So it reads apple and it copies it to standard out. And then it says, does that line that I just read match this pattern? Does it fall between lines 2 and 3? No, so it doesn't do anything else. It reads the second line, which is banana, it copies it to standard out. And then it says that line that I just read, does it match this pattern 2 comma 3? Well, it does because it's line 2, so it executes the instruction which says print, and so it prints out that line, banana, fruit, yellow. So we see that line again. So a lot of times we want the dash n switch because we want to control when sed produces something. But if we leave it off, sometimes we get strange looking things like this. Okay, so sed lets us print between certain regions. So this will print the first 5 lines. We can also say exclamation mark, which means if we don't match that pattern between 1 and 5. So this only prints out lines that don't fall between 1 and 5. So we can negate patterns. If we do this, this is going to look for a pattern that matches the regular expression fruit. And so this should only print out, with a P. So this should only print out our fruits. If we do that, it only prints lines that contain an I somewhere. If we do this, it'll print any line that begins with any character followed by the letter P. So any line that has a P in the second position, right, which is just apple, Spam, and spaghetti. There's a good meal. So you can do whatever you would like with regular expressions in here, right? This can be any regex. Right, so without the dash n, it copies from standard in, copies from whatever the input is to standard out, right? So we could do something like this. Let's say when we match line 3, let's quit. And since I don't have a dash n switch, the default behavior of sed is to read from the input and copy to standard out. So this should copy our first line and our second line until it gets to the third line. Right, so it reads those first 3 lines, copy them to standard out. After it read the third line, it said, does that line match my pattern, which is 3? It does. So it executes the command, which is quit, and sed terminates. Yeah?
So it recognizes like just the quotation marks as a valid program, just quotations and nothing else, as said, right?
Well, I'm pretty sure I could double quote.
Well, I mean, when you do said single quote, nothing in between, it reads that as
Yeah, that's a valid program. It's it's just an empty program.
Would it also read it as a valid program if you just did said single quote exclamation point single quote? Or does that,
Like this?
yeah, is that not like it?
It expects a pattern followed by an instruction, I believe. Although if I don't specify an address, right, I can put in just a P, and that'll print every line, so now I've just doubled every line of the file. But if I don't put in that quote, then it thinks that foods is an instruction, or the start of a program, and it gets confused about that. All right, so here's a slightly more complex program. It says on line 3 we should print, on line 4 we should print, and on line 4 we should quit. So this is a 3-line program. And if I do sed-n-f program 1 foods, this should quietly ingest from the input file, and on each line it should see if it matches any of these patterns. And so on lines 3 and 4 it should print, and then at line 4 it should quit. So it should just print the 3rd and 4th lines of our file, which are Oreos and kiwi. All right, we can also say A, which is add, and I, which is insert. And we can shove some extra stuff into our output. And this is add and insert as in VI, right? Insert comes after, add comes before. So A is append, and I is insert. So I is before, A is after. So here's another program P2. So this says on line 2, let's add the following text. So after it reads at line 2, it should say this was added after line 2. And then whichever line I'm reading from I want to print, right? I don't have a pattern on this P command, it's just an instruction. So it should always print. So there's 2 instructions in this program. If you're on line 2, add this to your input and then always print. So here's what our foods look like, apple, banana, Oreos. So let's do sed-n-fp2 foods. And so now we got apple, banana, and then we got this added line. This was added after line 2 right here. So here's a 3-line program. If we're on line 2, we should append this line after line 2. If we're on line 2, we should insert this line before line 2, and then whatever line we're on, we should print. So if I run this, all right, we get the first line, and then it says this was added before line 2, we get line 2, and then this was added after line 2. So we're picking apart an input file and we're doing things to it line by line, right? Awk, we were mainly working field by field, swap these 2 columns or add something between these columns and delete that 5th column, right? Sed is really working line by line. Print out each line twice if it matches this pattern. If it matches this pattern, print something before or after this line, things like that. All right, so here we can do the same thing, but our address is going to be a pattern here. So we're going to look for cookies. Make it more emphatic. All we got our cookies highlighted. I don't know why that first one didn't work. There we go. So now we got our cookies like nicely marked off. Right, so backslash as usual is a way to continue a command onto more than one line. You can do this in Unix, you can do it in most places in Unix. So here if we match the pattern cookie, we're going to insert, and then I say go down to a new line, right? So we've got a new line, and then here comes a cookie, and then we append, that was a cookie with an extra new line at the end. And so that puts new lines in there. Just making some sense? But I don't expect you to memorize this. I don't expect it to be something you can run off this afternoon and start writing sed programs, right, without thinking about it. I just want you to kind of see what sorts of things you can do with sed and with awk, and have it in your brain that these are available tools, so that when you get to something like, I got this dang caret m that I need to get rid of somehow, how can I do that, right? Think sed awk, something like that. All right, so you know about substitutes. Right, so this is the way we've been talking about sed for a while. We don't have an address specified, and so on every line it'll look for that regular expression and substitute it with whatever's on the right. So here I'm taking the beginning of the line followed by any two characters, which I'm putting into my first two registers, and I'm replacing those two characters with register 2 followed by register 1. And I'm doing that on foods, and that's just swapping the first two characters. This is back a few weeks now when we talked about regular expressions. We wrote some stuff like this. Right, so regex-based file manipulation, right, think sed. It's always there. It's your friend. All right, so one thing you can do with sed is sed-i. So sed-i program or -f program file followed by a file. This will actually change this file. Okay, this will actually do the substitution. So if I do sed-i, this thing on foods, and then I look at foods, it's actually got that stuff changed in the beginning there. So -i actually affects the file. Of course, if I do this again, it puts the file back to where it was. But -i you can also specify an extension. and it will make a backup of your file before it modifies it. So if I say sed-i dot save this, it creates a file named foods.saveThis, which is the unedited file. Right, and then it edits the actual file foods, and that's the one that's tweaked. So that can be useful for dealing with your reservations file. So here's the other thing you need on PA5. Right, so there's your reservations file, and you're trying to make a new reservation for a particular user. So you can do a grep on your reservations file, look for the name, and if grep returns something non-zero, the name wasn't found, you know it's a new reservation. So you don't have to worry about replacing an existing reservation. But if grep returns a 0, it means that it found a record with that user's name. So you've got a few options, which we've talked about before. Right, do a grep-v, and I think I still have there's my reservations. So if I do grep-v nick on reservations.txt, it shows me the records that don't contain nick, right? And so if I were to do this and put it into res2.txt, res2.txt is my original file with that record removed. And then I could just rename res2 to res, and that basically deletes my record. You can also use sed to do this. Okay, you can do sed-i and search for $$name pipe and put a delete command, and it'll delete that record. So you got options, but grep's a little lighter. All right, so back to sed. So exclamation mark is a negate on instructions. So if I say sed $P foods, so remember, default behavior of sed reads from input, copies the standard out. So this showed me my entire file, but my last line got output twice. So throw a -n, right? And this is a cheap way to just see the last line of a file. Basically, $ says if you're the last line, and my action should be P. But I could also say, if you're not the last line, delete. Right? So $ matches the last line, exclamation mark negates that, and my action is to delete. And so, oh, that's weird. What did I do? Oh. Yeah, I'm not printing anything. So if I take off the -n, right, then I delete every line except the last one. And then since the last line is not deleted, default behavior is to copy the standard out. Right, so here's a program with 3 substitutions. So if you want to do multiple substitutions at the same time, you can put them in a file. Sed dash fp5 foods. Right, so it does all 3 of those things. Or if you really don't want to have a file with your program in it, you could sed single quote this instruction P5, and then you could pipe that into sed single quote this instruction. You could pipe that into sed single quote this instruction, and have 3 versions of sed running, each doing one of these edits. It does exactly the same thing. All right, you always got options. We're almost out of time. How much more do I want to do on this? I'm going to save that. Bless you. All right, I'm going to post this up on Canvas, and I'm going to ask you to think about these. So here's some things we could try to do with sed, some of which we've already sort of done. I'll post this on Canvas presently. But kick these around in your head, and let's talk about them a little bit tomorrow. And see if you can come up with some sed programs that do this. We haven't talked about what we need to do number 5 yet, but I think the others you can do with what we've gone over. But we'll talk about dividing a file tomorrow. All right, so we'll start from there tomorrow.
Did you open up the